Hi guys, okay, so this video is going to be the first video of our very last unit for the year on limits and continuity. So today we're just going to talk about limits when looking at them from a graph, and then we're going to kind of, as the weeks progress, get into more algebraic approaches on how to find them and solve them. But today we're just going to stick to graphs just like this one. Okay, so the official definition of a limit states that if the y value of a function f of x becomes close to a single value L as x gets closer and closer to a point C from both the left and the right side, then the limit of f of x as x approaches C is L. Okay, and that's how we write it. I know that was probably like this big jumbled mess and it's not going to make any sense. It's just me reading it to you. So limits are basically, you just are kind of trying to find what is the function value going to be when you start approaching a certain point. So not necessarily the function value, but like what is the value. So if you see like this point right here, we have two different values. Okay, and so the limit is telling you what your function's approaching as your x value is approaching a certain value. Okay, so first thing we're going to do is we're going to look at this, this graph right here. Okay, and we're just going to start. We're going to look at what's our function value. So f of 4, f of negative 4, there's an open circle, so that it's going to be undefined. There's no function value at negative 4. Okay, next thing. So this notation right here, what this means, this negative 4 and the negative up top, that means we're going to approach negative 4 from the left. So what I like to do, I like to literally just trace on my graph. So I'm on my graph and I'm approaching it from the left. We're going up, up, up. Okay, we're going to hit 2. Alright, so you can have a limit at a hole. This is really important. Even if there's no function value, you can still have a limit because that's what your function is approaching at that point. Okay, so this next one, we want to see what's the limit as x approaches negative 4 from the right. That little plus sign in the corner means right. So we're going to go from the right. Alright, we're going to hit 2 again. Alright, so since our limit from the left and our limit from the right are the exact same, then our limit as x approaches negative 4 is just going to be 2. Okay, so for your limit to exist, it needs to be the same from the left and the same from the right. Your function does not necessarily have to have a value at that point. So just like this one, we have no value at negative 4, right? But we do have a limit, and that limit exists since the left and the right are the same. Okay, let's try this again. At x equals 1, our function value is going to be 4, because that's where our closed circle is. Alright, now we're going to approach 1 from the left. So from the left, we're going to come up. Alright, we hit 4. Now I need to approach 1 from the right. So we're going, 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 and we hit negative 2. Alright, since our limit from the left and our limit from the right aren't the same, the limit as x approaches 1 does not exist. Okay. Alright, next one, f of 6. Alright, so our function value at 6, when x is 6, is going to be 2, because that's where our closed circle is. Alright, so now we need to approach it from the left. So we're approaching 6 from the left. That's going to give us 5. If we approach 6 from the right, that's also going to give us 5. So then our limit as x approaches 6, since our left and our right are the same, is going to be 5. Okay, so these are like the three main different cases you're going to see with limits. When there's no function value, there's a hole, but your left and your right's the same. When there's this sort of like jump, this big change, and then the left and right are different. Okay, so then our limit doesn't exist. And then similar as before, when there's a hole and we do have a function value. Okay, the only one not shown is if there was actually like this was filled in, but that's super straightforward. Your value would be the same as your left limit, your right limit, and then your just overall limit. Okay. So the next thing we're going to talk about are limits when there are asymptotes involved. Okay, so a one-sided limit, that's just like what we were doing right here with when you're only approaching the left or you're only approaching the right. So that's just one side. two sides is when you're looking at the limit as a whole. So your left and your right need to match for your two-sided limit to exist. Okay? So for a one-sided limit, when we have vertical asymptotes, it's either going to be negative infinity or infinity. So there's two options when we have two-sided limits, right? First one, we're going to have if they both approach the same infinity or negative infinity, right? So if they both approach infinity, the limit's going to be infinity, right? If they both approach negative infinity, it's going to be negative infinity. The problem that we run into is if they approach different infinities, right? So say from the left it approaches positive infinity, but the right it approaches negative infinity, we have to put does not exist, right? So if it's going two different ways, that's not going to exist, right? We can't have that. They're too different, and that limit just does not exist. Alright, so for number 13, there are little typos down here. All of these are negative 3s and 6s. They should all be positive. They're right on the key, and they're right in the notes packet that I posted, so just on my copy they're wrong. So first one, if we want to approach 3 from the left, if we go, we see that our value is going to go all the way up and up and up right next to that asymptote. So that's going to be infinity. Now if we want to go from the right, it's down here. We see our function going to go all the way down. So that's going to approach negative infinity. Okay, so since they approach two different infinities, our limit does not exist. Okay. So now let's try with 6. So if we approach 6 from the left, we see that's going down, 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 down. That's going to be negative infinity. Number 17, if we approach it from the right, we see it's going down, 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 also towards negative infinity. So the limit, as f of x x approaches 6, right here, since they're both going to negative infinity, is going to be negative infinity. Okay, so looking at a graph, they're not too bad. Just most important thing when you do have a graph like this and you don't have asymptotes, you can have a limit at a whole. Okay, that's like the weirdest thing to kind of grasp, and that's like personally what I struggled with the most, but you can have a limit even if there is a hole. Okay, so next thing, we're going to look at some piecewise functions. Okay, so when we do that, we're going to go ahead and graph them. Let's see. There's going to be another way that you guys will learn how to do these that I personally prefer, but if you like graphing, all power to you. Right now we're just going to stick to graphing. So when we graph it, this first one, I'll go ahead and graph in green. Right, so we're just graphing from x is less than 0. That's going to go right up here to -1. And there's an open circle, right? So this is -1. And then when you graph the second function, this quadratic, that actually also starts at -1, but that's going to give us a filled in circle. It's going to look something like that, okay? So now what we do is we're going to look at the limit of f of x as we approach 0 from the left, and then we're going to look at the limit as we approach 0 from the right. And then if they're the same, we'll know if the limit exists. Okay. These little dots, they just mean therefore. Mathematicians are inherently very lazy, right? And so that's the little shorthand that we have come up with for how to write therefore. Alright, so we're going to approach 0 from the left. So we're going to come from the left. That's going to give us -1. We're going to approach 0 from the right. We're going to come down. That's also going to give us -1. Since our left and right limits are the same, then that means our limit as x approaches 0 of f of x is going to equal -1. Okay. This next one, go ahead and graph this one. Alright, so the first one, again, I'll do in green. That's going to go to right here, approximately. Right, so this is at 4. Alright, our next important value is going to be right here at 2. So we know that when x is 2, from 2 to 6, our function only equals 2, right? So this is going to be a nice straight line. Right? And then our last one, I'm going to graph right here in the purple. That starts when x is greater than 6. That's just going to come straight down like that as a straight line. Okay? So the one we're concerned with is 6. So we need to find the limit as x approaches 6 from the left of f of x, the limit as x approaches 6 from the right of f of x, and then we'll know what's going on with our limit as x approaches 6, just as a whole. Okay, so approach 6 from the left, that gives us 2. We approach 6 from the right, it's going up, it's also going to give us 2. So since our limits from the left and the right are the same, the limit as x approaches 6 of f of x is 2. Okay. So the function for number 21 is actually the exact same, so I'm not going to bother redoing the graph. We're just going to look at it right here. So we want to find, but this time we want to approach 2 instead of 6, right? So we can find the limit as x approaches 2 from the left of f of x, the limit as x approaches 2 from the right of f of x, and then we'll know what's going on with our limit as x just approaches 2. If it exists, if it doesn't, all of that. Alright, so we want to approach 2 from the left, so we go up, up, up. That's supposed to be at 4, but so our limit as we approach 2 from the left is 4. Now we need to approach it from the right. Alright, so we're following this line. Oh, that's going to give us 2. So, what's going to happen now that our left and our right limit are different? That means the limit as x approaches 2 does not exist, right? Because it's 2 different values. If these were the same, just like in number 20, then it would exist, but it does not exist since our left limit and our right limit are not the same. Right. Last example for this note section, we're going to go ahead and graph this one as well. So I'm going to graph it. Let's see, there you go. Now you can see it. Alright. So the point we want to focus at is when x is 0, and then also 4, since that's part of our piecewise function, right? I'll graph this first one in green. Alright, so when we graph this one, it's going to look like this. There's going to be an open circle at -3. Okay. Next one, I'll go ahead and graph in blue. And this, from x is 0 to 4, it's just going to be -3, right? So just like before, this is going to be a straight line right across here. Right? And then lastly, I'll graph this part in purple. And so when you plug in that 4, it's actually going to be, it's going to start at +3. Okay. So this will give us an open circle right here. And then it goes off just like that. So now we need to find our limits. So the limit as x approaches 0 from the left of f of x, the limit as x approaches 0 from the right of f of x, and then we'll know about the limit just as x approaches 0 as a whole. Okay? So we want to approach 0 from the left, right? So we're going to come down. That's going to give us -3. Now we need to approach 0 from the right. Again, we're going to get -3. So since our left and right limits are the same, our limit as x approaches 0 is going to be -3. Okay. Hopefully from a graph, they're pretty straightforward. Again, the biggest thing to remember is that you can have a limit at a whole. Your function value does not have to be the same as your limit value. And yeah, that's kind of it.